Hi guys! Welcome back to our channel. I'm Eula Vidal, and for today's video, I will teach you the Laplace transform. Okay, to begin with, what is a Laplace transform? Okay, the equation above tells us that the Laplace transform of function of t is equal to the integral of e raised to st times function of t dt from 0 to infinity. The purpose of Laplace transform is to transform all the ordinary differential equations into algebraic equations to easily solve the ODEs. Now, let's solve some equations and have some bunch of examples. For this one, we will use first the two most common formula equations that can be seen in some problems. So let's say we will use first the Laplace transform. The Laplace transform of a constant is equals to a constant, the constant itself, the number itself, over s. And the Laplace transform of t raised to its exponent, denoted by n, is equals to the n factorial over s raised to n plus 1. Okay, let's have some example for this one. Let's say we have f of t. F of t, function of t, is equals to t raised to 5. First, let us determine what is our n. Our n here is, yes, it's 5, number 5. For this example, we will use this equation. Okay, we will get the Laplace transform of both sides. The Laplace transform of f of t is equals to the Laplace transform of f of t raised to 5. Substituting the values, we will have 5 factorial over s raised to 5 plus 1. 5 factorial is also equal to 5 times 4 times 3 times 2 times 1 over s raised to 6. Let me write it directly. So the Laplace transform of f of t is f of s. Let me write it. F of s. And 5 times 4 times 3 times 2 times 1 is equals to 120. Over s over 6. This will be our final answer. So for this one, we used f of s. You may be wondering why. So f of s is the Laplace transform of the function of f transformed into the s domain. Since we used a variable of s here in the right side. Okay, let's have some example for this one. Let me erase it. Let's say we have this one, including the constant, the Laplace transform of a constant. Let me just erase it. Okay, let's say we have a function of t is equals to t raised to 3 plus 5t plus constant plus a constant of 6. Here we will get the Laplace transform of each term. So here, let's write again the Laplace transform of f of t. This one is for the beginners to easily determine the n. But if you are now used in solving this problem, this kind of equation, you can now just directly compute the exponent as factorial as over s, like that. Okay, let's say we have, let me just arrange it. the Laplace transform of f of t is equals to the Laplace transform of t cubed plus, okay, the coefficient 5 here, the 5 here will be just a multiplier to the factorial. So let's put 5 outside. 5 times the Laplace transform of t plus the Laplace transform of 6. So for this one, we will have, for the first term, we have our n, 3. Now, let's just substitute it. 3 factorial over s, 3 raised to 3 plus 1. Then we have, we have this 5 times, now let's just write the 5 and a parenthesis for the factorial. Our exponent here is 1. So let's write 1 factorial over s1 plus 1. And our constant, for our constant, here 1, let's use this one. Our constant is 6. And the Laplace transform of it is 6 over s. Okay, 3 times 2 times 1 is 6. S raised to 3 plus 1 is 4. So we have s to the 4th power. Plus 5 times 1 factorial. 1 factorial is 1. And times multiplied to 5, it will be 5 over s. 1 plus 1 is 2, so s squared. Plus 6 over s. And our function of f of s, function with s to mean. Now, this is our final answer. Our final answer is f of s is equals to 6 raised to 6 over s raised to 4 plus 5 over s squared plus 6 over s. Okay, now let's proceed to the next equation or formula that we will be using. Let's say, let's use the, this one. Let's use the Laplace transform of e, our natural number, e raised to a, which is a number 2, natural number, a multiplied to t. The Laplace transform of this one is 1 over s minus a. Here we will determine what is our a. So let's have an example for clarification. Let's say we have an example of f of t is equals to e raised to, let's use negative 2t. Negative 2t plus 5 e raised to negative, what's this? Raised to negative 3t. So for this example, let us determine, let us first get the Laplace transform of this one. Laplace transform of f of t is equal to the Laplace transform of e raised to negative 2t, and our multiplier 5 here for the second term, 5, then the Laplace transform of e raised to negative 3t. So for the first term, we have our a, let's determine our a. Our a is negative 2, and for the second term, we have our a as negative 3. Okay, substituting it to this one, we will arrive with 1 over s minus negative 2. Okay, let's put equals plus 5 times 1 over s minus negative 3. Multiplying this one we will have 1. S minus negative 2 is S plus 2, positive. Negative times negative is positive. Plus 5 over, same with here, negative times negative will be positive, S plus 3. Okay, so this will be our final answer. That's easy one. Now let's proceed to the trigonometry. Okay, now let's proceed to the sine, cosine, and the hyperbolic sine and cosine. Okay, now let me just write here our formula or our equation of the Laplace transform from the Laplace transform table. The Laplace transform of sine, of sine AT, A is a number, is equals to A over S squared plus A squared. And the Laplace transform of cosine AT is equals to S over S squared plus A squared. Okay. Now let me just write then the hyperbolic one. The Laplace transform of hyperbolic sine hyperbolic, sine H, sine hyperbolic, A T is equals to A over S squared minus A squared. Hyperbolic ones are the S squared minus A squared denominator. Look at this one. The Laplace transform of hyperbolic cosine or the cosine hyperbolic is hyperbolic cosine is equals to S over S squared minus A squared. Okay, now let's have some example first for sine and cosine. Okay, here let's say we have the Laplace transform of sine. Let's get the Laplace transform of sine 3t. So our A here is 3, right? So substituting, just using this formula, this given formula, we will arrive with 3 over S squared plus what is our A is, it is 3 squared. Now the Laplace transform of sine 3t is equals to 3 over S squared plus 9. That's so simple. Now let's use the cosine. So the Laplace transform, let's get the Laplace transform of cosine 40. Here our A is 4. Using this one, we will just substitute A in the denominator. So we will have S over S squared plus A squared. 4 times 4 is 16. And this will be our final answer for the Laplace transform of cosine 40. Now let's use the hyperbolic one. Let me just erase this one. For the hyperbolic one, let's say we have hyperbolic sine h and with an a of 3. Let's use 3. Same with sine. Let's use 3t. Our a here is 3. Substituting here, we will have 3 over s squared minus 3 squared. Now we will arrive with 3 s squared minus 3 squared is 9. So this will be our final answer. Now let's proceed to the hyperbolic of cosine. Let's say we have 40. Let's use 42. 40. Our a here is 4. So substituting here, we will arrive with s over s squared minus 4 squared is 16. S over s squared minus 16 is our final answer for this cosine, hyperbolic cosine. Okay guys, those examples are simple. Now, let's say you will encounter a Laplace transform of a cosine squared at. It is just the same, but first we will use some identities to rearrange, transform these equations. So cosine squared is equals to, remember the power reducing identities. Cosine squared is equals to, let me write it, cosine squared u, or the number, is equals to 1 plus cosine 2, not squared, but 2u over 2. Okay, let's use this one since it is just equal and our u here is 80. Okay, so let's rearrange and transform this one. Laplace transform of a 1 plus cosine 2, our u is 80, 280 over 2. The 2 here will be distributed as denominators of both terms. Let's say we have the Laplace transform of 1/2 plus the Laplace transform of, there is an invisible 1 before the cosine, so let's have 1/2, 1 over 2 as a multiplier. 1/2 Laplace transform of cosine, cosine 280 here. The Laplace transform of a constant, since 1/2 is a constant and no variable with it, it will be equal to 1 over 2s plus, okay, let's put the 2 here, 2, the 1/2. Okay, for this one, we will just use the normal cosine equation, which is the s over s squared plus a squared. So s 1s over 2, and our denominator for this one is s squared plus s squared. So s squared plus our a here would be 2a, since 2 is the multiplier of a here in our given. So 2a. Now let's combine 1 over 2s plus s. You can just write it as s since it is just 1. Distributing the factors. Oh wait, this would be squared. Sorry, this would be squared. Now 2 times s squared is 2s squared plus 2a squared is 4a squared times 2. It would be 8a squared. We can just simplify this one. We can further simplify this one, absolutely. But this can be our final answer. 1 over 2s plus s over 2s squared plus a is 8a squared. Just remember all the identities, and it will help you a lot to transform and change the equations to easily solve them. Okay, now let's use the last two formula from the Laplace transform table. Let's say we have the Laplace transform of f double prime of t is equals to s squared times y of s minus s times f of 0. F of 0 would be given since it is the condition of our given example. Minus f prime 0, these two. Okay, while the Laplace transform of f prime t is equals to s times y of s minus f of 0. F of 0 will be given. So let's say we have, well, our y of s would be the Laplace transform of y of t. Okay. Let's say we have an example of y double prime minus 2y prime plus y is equals to 3e raised to t. T is our exponent with the condition of y of 0 is equals to y and the y prime of 0 is equals to 1. First, let's get the Laplace transform of each term by writing the Laplace transform of y double prime minus 2. 2 is our multiplier as well as the 3 on the right side. 2 times the Laplace transform of y prime plus the Laplace transform of y is equals to 3, our multiplier, times the Laplace transform of e raised to t. For the third term, we will use the 1 over 3a, 1 over s minus a, and the Laplace transform of e raised to at. Okay, now let's just substitute this value to this one, this value to this one, and this one to this. Okay, we will put now just brackets to prevent the messy and disturbing equation. So we have s squared times y of s minus s times f of 0. F of 0 is this one. We have 1 times 1. Let's just substitute it right away. Minus 1 here, the y prime, the f prime. Okay. Minus 2. 2 will be our multiplier here. So 2 times y prime is equals to s times y of s minus 1. Then the Laplace transform of y is equals to y of s itself. Here on the right side, we have 3 times 1. Remember that e raised to 80 is equals to 1 over s minus a. Our a here is 1 since there are no other coefficients or numerical value before the t. So 1. 3 times 1 would be 3. Okay, let's combine like terms and distribute the multipliers. Let's just copy this. S squared times y of s minus 1 minus 2 times s times y of s is negative 2 times s times y of s. Negative 2 times negative 1 would be positive 2. So just 2 here. Plus the y of s. Here, just copy this s minus 1. Let's combine like terms. And let's just all transpose the term with no y of s as their multiplier, we should isolate the y of s here to get the values of a, b, and c by partial fractions. So first, let us underline what should be transposed here, and this one. This should be plus. Okay, and let's put y of s outside since it is the common multiplier of these three terms, and just put the s squared minus 2s plus 1. And then we will have 3s minus 1, the transpose. Remember that in transposing, we should change the signs. So it should be positive s. Negative 1 plus 2 is 1. So it will be transposed, it will become negative 1. We should get the LCD of these three. But now let's just isolate the ys by dividing both sides by s squared minus 2s plus 1. S squared minus 2s plus 1. Wait. Cancel this, and here the equivalent of this one would be 4 minus 2s plus s squared. Let me just rewrite it. Over s minus 1, s squared minus 2s plus 1. Okay. Rewriting this, we should arrive with 4 minus 2s plus s squared over its denominator, s minus 1. Okay, s squared minus 2s plus 1 is also equivalent to the s minus 1 squared. By rechecking it, you should use FOIL method for easy understanding. So, we need s minus 1 times s minus 1. Use the FOIL first, outside, inside, and last. S squared. Negative s, the inside is negative s also, and the last should be negative times negative 1 is positive 1. So s squared, combining like terms, we will arrive with s squared minus 2s plus 1. 2s plus 1. So we could also rewrite this with s minus 1 squared, or 4 minus 2s plus s squared over s minus 1 cubed. Now we will use the partial fractions, and the purpose of partial fraction is to get the values of s squared, the s, and the constant itself. Now let's say we have y of s is equals to s squared. Let's just copy this and rearrange the, let's just use the proper arrangement of the ax squared plus bx plus c, the exponents, and its form s squared minus 2s plus 4 over s minus 1 cubed. By using partial fractions, we will arrive with a over s minus 1. The other one should be b with the square, s minus 1 squared denominator, and c with the cube denominator, c s minus 1 cube. Multiplying both sides, we should just, this one should be cancelled, and by doing that, we need to divide both sides by is minus 1 cubed. Here we will arrive with y of s is equals to s squared minus 2s plus 4 equals to a s minus 1 squared, reducing its exponent. Since we have 1 here, 3 minus 1 is squared is 2. So you'll have a times s minus 1 squared plus b s minus 1 s minus 1 with the exponent of 1. Since 3 minus 2, it would be 1. Plus the c itself, since s minus 1 cube will be cancelled since we have a denominator of s1 minus 1 cube here with our c. Now let's say now let's square this term. We will arrive with, let me just write this one, s squared minus 2s plus 4. S minus 1 squared is equal here. So A times s squared minus 2s plus 1 plus B s minus 1, just copy, and C. So here, we need to distribute this thing here and this one here. I'll copy this again. S squared minus 2s plus 4 is equals to as squared minus a 2s plus a plus b s minus negative b plus c. Then we should combine like terms and we will arrive with s squared minus 2s plus 4 is equals to, since we only have one s squared here, let's put it here, as a squared minus since we have single exponent of s here with a and b, we will put the common multiplier outside s and multiply it with the remaining ones, a2 plus b, and then copy this one, a minus b plus c. Okay, here let's look on the left term. On the left term, we have our s squared here with a coefficient of 1. So we should conclude that our a, since it is the s squared, a is equals to 1. Now we can substitute the value of a here to get the value of b. By doing so, here on the left side we have a coefficient of negative 2 with our s. So let's put negative 2 is equals to our s. We should not write s anymore since we have it here. We just get the value of those things. Negative 2 is equals to a2 plus b. Negative 2 is equals to a. Our a is 1. So 1 times 2 plus b. And transposing this one, negative 2 times 1 is 2. It will be negative 2 is equals to b. No. Okay, for clarification, our negative only here is the a2s, so this should be positive, the positive s, since we have a positive b, and this should be negative. I'm so sorry, but we'll just fill. Okay, negative a2. So this will be, we need to transpose this one, but first let's substitute a with our value. A is equals to 1. Negative 2 is equals to negative 1 times 2 plus b. By negative 2 is equals to negative 1 times 2. Negative 1 times 2 is negative 2 plus b. Transposing this, it will make positive plus b. This will be equal to 0, and our b is 0. Now we can get the value of c by means of the 4 here is our constant, and on the right side we have a minus b plus c. These are our constants. So putting it here like this, 4 is equals to A minus B plus C. Since we have the values of A and B, we just substitute it. A is 1 minus 0, B 0 plus C. Then transpose it to get the value of C. So 4 minus 1, disregard this, then we will have the value of C. 4 minus 1 is 3. And that serves as the value of C. And this would be the answer to our equation above. So that's it for today, guys. I hope you learned something new. I hope you learned the concept of Laplace transform and you know how to apply it on your future problems or with the equations. And I apologize for the last clip. I wasn't able to show my face explaining this one because my phone had died. But I provided a sketch pad with you. You have watched it. And I hope you understand it. Thank you.